We have the third operation, which is the multiplication of functions. Still, we will use the two functions f and g with domains d sub f and d sub g respectively. The product of f and g, denoted by f times g, is the function defined by f times g of x, which is equal to f of x times g of x. So it has the same definition for addition and subtractions. It's just that the difference is the operation. The domain of the product of the two functions is the intersection of d sub f and d sub g, or the intersection of the two domains. So for example number 1, we have here f and g functions. So f function is x plus 5 and g function is negative 4x minus 20. We determine or solve the product of the two given functions. So let's have f times g of x, and by definition that is f of x times g of x. We substitute the given functions, x plus 5 for f of x times negative 4x minus 20 for g of x. Okay, then we just multiply the two binomials by applying FOIL method. X times negative 4x is negative 4x squared. Positive 5 times negative 4x is negative 20x. X times negative 20 is negative 20x. And 5 times negative 20, it's negative 100. Okay, we combine like terms. Negative 4x squared. Negative 20x minus 20x is negative 40x minus 100. So the product of f and g function is negative 4x squared minus 40x minus 100. So in getting the domain of the two functions, take note that the two functions given are linear functions, so the domain is the set of all real numbers. And if you will get the intersection of the domain of f and the domain of g, that will still be the set of all real numbers. Let's have the second example. G of x is equal to negative 4x minus 20. M of x is equal to x squared minus 4x plus 4. We solve for the product of the two given functions, g and m. So let's have here g times m of x, by definition, that is g of x times m of x. Okay, then we substitute the functions. We have here negative 4x minus 20 times x squared minus 4x plus 4. Okay, so we just multiply the two terms. Okay, so we have here negative 4x times x squared is negative 4x cubed. Negative 4x times negative 4x is positive 16x. Negative 4x times positive 4, it's negative 16x. Okay, next we have here negative 20 times x squared is negative 20x squared. Negative 20 times negative 4x is positive 80x. And negative 20 times 4, it's negative 80. Okay, now we can combine like terms. We have here negative 4x cubed. This should be squared. Okay, yeah. So we have here 16x squared minus 20x squared it's negative 4x squared. Then we have negative 16x plus 80x, positive 64x, and we copy negative 80. Okay, so I made a correction on this part. This must be squared. It's because negative 4x times negative 4x is positive 16x squared. For the domain, okay, so one function is a linear function, that is the g function, and the other function m is a quadratic function. But take note that their domain is the set of all real numbers. Okay, so domain of g times m is still the set of all real numbers. For the third example, we have f of x, which is equal to x plus 5, and n of x is equal to square root of 2x minus 1. We get the product of f and n functions. Okay, so f times n of x is equal to f of x times n of x. Okay, we substitute the functions. X plus 5 times square root of 2x minus 1. Okay, so a square root of 2x minus 1 is like one term. So we multiply this one to x plus 5. Okay, so x square root of 2x minus 1 plus 5 square root of 2x minus 1. So that is the product of f and n function. For the domain of d sub f is the set of all real numbers, while the domain of d sub n is all real numbers greater than or equal to 1/2. Okay, to make the function defined. And so the intersection of the two functions, d sub f times n, is all real numbers greater than or equal to 1/2. To make the new function defined in consideration to n of x. So for our next example, we have here the f and the p function. F of x is x plus 5 and p of x is 3x plus 1 over x squared minus 25. So we get the product of f and p functions. So f times p of x is equal to fx times p of x. We substitute the functions. X plus 5 times 3x plus 1 over x squared minus 25. Okay. For multiplication of functions, you always observe the terms, okay? Most especially if we can apply factoring, so that we can also use a cancellation method. Okay, on this denominator, x squared minus 25, that is factorable, and the factors of x squared minus 25 is x minus 5 and x plus 5. Okay, so we have here x plus 5 times 3x plus 1 over x plus 5 and x minus 5. Okay, so we can cancel now x plus 5 and another x plus 5 on the denominator. So what's left is 3x plus 1 over x minus 5. So that is the product of f and p functions. For the domain of the new function, the domain of d sub f is the set of all real numbers, while for d sub p, okay, -5 and +5 are the excluded values. Okay, for our solution, it's because if we will substitute -5 or +5 to the value of x on the denominator, then it will make it 0. Okay, so we have here all real numbers less than -5 union of -5 5 union of all real numbers greater than 5. Okay, and when you get the intersection of the two domains, d sub f times p, okay, so the intersection of the two domains is all real numbers less than -5 union of -5 and 5 union of all real numbers greater than 5. So that is the domain of the new function, and also we need to consider the two given functions. Let's have our fifth example using j and m functions. J of x is equal to 2x plus 4 over x minus 2, while m of x is equal to x squared minus 4x plus 4. We solve for the product of j and m. So j times m of x is equal to j of x times m of x. J of x is 2x plus 4 over x minus 2 times x squared minus 4x plus 4. Then we have here 2x plus 4 over x minus 2. Okay, take note that x squared minus 4x plus 4 is factorable, and the factors of the trinomial is x minus 2 times x minus 2. Okay, so in doing that, we can cancel one of these two binomials and of course the denominator. Okay, so what's left is 2x plus 4 and x minus 2. We just multiply the two binomials. We have here 2x squared plus 4x minus 4x minus 8. Okay, we combine like terms. 2x squared, that is 0 minus 8, and that is the product of j and m functions. Okay, for the domain, d sub j has a domain of, okay, all real numbers less than positive 2. Okay, I repeat, all real numbers less than positive 2. Union of all real numbers greater than 2. Okay, why 2? It's because when we equate that one, x minus 2 equals 0 to 0, x is equal to 2. So when you substitute 2 as a value of x on the denominator of j, 2 minus 2 is 0. Okay, and it cannot be that the denominator is 0. While for the domain of m of x is the set of all real numbers. So we get the intersection of the domain of j and p, and that is all real numbers less than 2 union all real numbers greater than 2. Let's have our last example for multiplication of functions. We have here j of x, which is equal to 2x plus 4 over x minus 2. P of x is equal to 3x plus 1 over x squared minus 25. So we get the product of the two given functions, j and p. So j times p of x is equal to j of x times p of x. Okay, we substitute the functions. We have here 2x plus 4 over x minus 2 and times 3x plus 1 over x squared minus 25. Okay, when we deal with examples like this, you have to recall how to multiply fractions. Okay, so we have here a over b times c over d is equal to ac over bd, meaning numerator by numerator, denominator by denominator. Okay, so we multiply the numerator first. 2x times 3x is 6x squared. 4 times 3x is 12x. 2x times 1 is plus 2x, and 4 times 1, that is positive 4, over, we now multiply the denominator. X times x squared is x cubed. Negative 2 times x squared is negative 2x squared. Positive x times negative 25 is negative 25x, and negative 2 times negative 25, that is positive 50. Now we combine like terms. For the numerator, we have 6x squared. 12x plus 2x is 14x plus 4 over, for the denominator, x cubed minus 2x squared minus 25x plus 50. We just copy the denominator. It's because it does not have any like terms. Okay, and that is the product of j and p functions. So for the domain, okay, so we will look into the value of x that we will exclude, okay, on the solutions or on the domain. So for d sub j, the domain of d sub j is all real numbers less than 2, union of all real numbers greater than 2. Okay, while for d sub p, the domain is all real numbers less than negative 5, union of negative 5 and 5, union of all real numbers greater than 5. So the intersection of the domains of j and p function is, okay, we use the number line so that we can verify. On this side, we have negative 5, excluding negative 5. We have here positive 2, exclude also positive 2, and of course exclude natin positive 5. Okay, so based on our number line, the intersection will be all real numbers less than negative 5, union of negative 5 2, union of 2 5, and union of all real numbers greater than 5. Okay, so that is the intersection of the domains of j and p.